Hey everyone, my name is Dipankar and I'm a developer advocate here at Dremio. Welcome to another episode of Select Star from Data Lake. In this particular episode, I want to talk a little bit about the performance strategies or the optimization strategies in your cloud data lake with Apache Iceberg as the table format. So let's say you have adopted Iceberg as a table format, right? You can now perform various operations like inserts, updates, deletes directly on the data lake data. And most importantly, in a transactionally consistent way. Now everything is going great, right? Your data is an open format, multiple engines can use the data based on their specific requirement, and you don't really have to pay a hefty cost for a data warehouse to run your compute. But that's really just the beginning of your journey, right? You want your lakehouse to be operational and functional. So that means you will have various sources ingesting data in your data lake storage. And over a period of time, the number of data files in your data lake, they're just going to increase by a lot. So what this means is if an analyst within your organization was using a SQL query to get some data, the performance might not be the same as it was before with your lakehouse. And the reason being, obviously, because we have so much of data coming into our data lake, right? So the gist of all of this is that querying hundreds of petabytes of data, or for that matter, any kind of even a smaller data from a data lake requires optimized query speed. And obviously your queries can be fast today, but maybe they might not be over a period of time. And there are a lot of reasons because of why. First, your query patterns may change, right? New query patterns may be added. Or, the queries may be just slow because you don't have files organized in a way that really gives the best of the performance. So if we have to go and find out the main issues about all the performances, the main problem is that you end up with a lot of unorganized files and small file issue. Okay, so do we have a solution to this problem? Well, the only solution to this whole problem of getting more faster queries is basically to read as less data files as possible. So in the best case, we basically need to fetch data from the exact set of files present in a data lake that are required to answer a particular query with. Okay, and obviously, but that it's not a very easy game, right? It's a tough game with so much of data, large storage system, and so many processes running in, so many ingestion happening. So the idea is to be able to just skip some of the files. And what I mean by that is that if you could just let our query engine skip the non-relevant file, that would basically give us whatever we need for our query, isn't it? And that brings us to what we can do to optimize this particular process and make our queries faster. And basically, this is where Apache Iceberg shines and brings along things such as partitioning, compaction, metrics-based filtering, and all those things that kind of we are going to give a high-level overview today in this particular episode. So one of the common strategies that people utilize is partitioning, right? Partitioning, as we all know, is basically, it's a way to make queries faster by grouping similar rows together when we are writing the data. So when we apply partitioning to a particular table and partition by a particular, way, we will have group of files within that particular, within that particular variable. Okay. So for example, if you have, let's say a log table and you partition by date of that particular event time, you will see a partition for, let's say, event date 1st December, there will be partition for 2nd December and so on, right? So what we are essentially doing here is we are basically grouping similar type of files which came on 1st December in a similar partition, okay? And so now instead of looking into the entire table of data files for a query engine basically has to go and look for that particular partition. So for example, if your query is something like select star from this particular table where the log event date is 1st December, then our query engine has to basically go and look for only that partition table. Okay, so we don't need to worry about other partitions. So partitioning basically allows us to do file skipping and help ensure performance, and that's basically the main benefit of partitioning. What Iceberg brings to the table and kind of elevates that thing is something called hidden partitioning. So what Iceberg does is it does handle the tedious and error-prone task of producing these partition values for rows in a table. So if we go to the world of Hive table format, we basically needed to explicitly add a partition column in that particular table with which we are applying partitioning. So this means that the user, they will require you to know the physical layout of the table, which is a lot tougher when you're evolving things like partitioning, right? When you're changing the partition strategies. So that is something that Iceberg brings. Second, technique that is widely common is something called compaction. So when you're ingesting data frequently in your data lake, specifically with streaming data, there may not be enough new data to create optimal data file sizes as we would want. Okay, so this means that we would end up with a lot of smaller number of files in a data lake table, and which can really impact the performance of all the query engines. Well, the reason for that is that first, the number of operation in that particular file grows, right? You have to open that particular file, you have to read the content of the file and close the file, and you have to do this for every single file in the data lake. So you would not want to read more number of smaller file, whereas in contrast, you would want to read a large record at one single time. Okay, and that is why you basically need to compact the smaller files into a larger block of file, which is what is called compaction. And Iceberg by default bring techniques like bin packing, through which you can compact smaller file into larger one, or even break down a larger file to smaller ones. So this is a really interesting thing and technique that Iceberg by default provides it. It's just if you're using something like Spark, you can just call a sort procedure to compact the file. Next, another important thing is metrics-based filtering, and this is a pretty interesting one. So metrics-based filtering is basically a way to read less number of files and skip the non-relevant one. So there are certain file formats like Parquet or they basically keep certain metadata information about them in the footer, right? So for example, if there is a employee table with certain number of columns, we will have a minimum and maximum value for each of those records. And in that way, if I have a query, I can basically compare that particular value in the filter with my mean and max range and decide to just skip the file if it's not within that range, right? Which is great. But what Iceberg brings to the table is that it actually aggregates this metric-based files into a separate metadata file called manifest file, which basically allows us to do a second level of pruning, right? Which is really amazing. But even with those kind of scenarios, there might be things like, overlapping metrics. For example, there might be two files where you have similar ranges of, values, right? The min max ranges that I was talking about. So what do you do when you have similar kind of scenarios? Well, in that case, a common strategy to deal is to just sort the data, just reorder the data in a way that each data file ends up with a unique range of values for that particular column. Okay. So obviously sorting is a great technique. You can order the data in a way, you're basically, rewriting the data in a way that you would want to, and basically organizing it in a way that your query engine doesn't really fall into that overlapping metric condition. Okay. Another thing that kind of like pops up in my head is really important with sorting is called multidimensional sorting, which basically is you want to sort using different dimension or different fields at the same time. Typically what would happen when you were using hierarchical sorting, for example, you sort something by employee ID and then you sort the data by employee name, right? Usually the sort will happen based on the first filter predicate, not on the second part, because the sorting is going to be happening based on that first particular column, and it's going to organize the rest of the data based on that particular column. So in this kind of scenario, you would not really take advantage of a filter if the predicate is on the second sorted order. Okay, so this is a particular scenario when you would like to leverage something called multidimensional clustering, and this is where techniques like Z ordering comes into the picture. So Z ordering is basically a technique where you kind of like use multiple dimensions at the same time and calculate a Z value, and using that particular value, you basically can organize or cluster your data so that you don't end up with the problem that we initially discussed with multidimensional sorting or overlapping metrics kind of scenario. And this way, another important benefit that comes off of this particular technique is that you can basically co-locate data. That means you can put together similar data points in a similar file. So for example, things like geospatial data, right? Where you have latitude and longitude, right? In this kind of scenario, you would want latitude and longitude of cities, for example, to be similar, right? For example, if you're thinking about Toronto, you would want something like Ottawa to be close to Toronto, right? Because they are geographically very closer. So this kind of scenario is pretty much common that you see with larger analytical operations, and that might be something of your interest as well. So Apache Iceberg provides the ability to basically, zero read data and do your clustering in a way that basically uses multiple dimensions. That is all I wanted to discuss today. So we kind of spoke about different techniques here in this particular episode, like with techniques like partitioning, compaction, mean max filtering, and then came sorting and Z ordering, right? So I think if we have a proper strategy defined to, invoke these particular methods at a particular time as per your organization's goal, I think that will really benefit us with all those performance benefits when we are dealing with large scale data, or even for that matter, even data from cloud data lake, any scale of data from data lake. So thank you so much for listening. We'll see you in the next one.